Good day everyone. In this video, I will going to discuss and explain some of my answer in our final examination, which is the problem solving.
Number 1. A. Calculate the pH of the solution that is 0.100 molarity methylamine of NH2CH3 and 0.400 molarity of sodium methylamine. So here is the solution of this problem. Cm of CH3NH2 equals 0.1 molarity. CH3NH2 plus H2O or water equals CH3NH3 positive plus OH negative or hydroxide. 1 mole CH3NH2 to 1 mole OH negative. 0.1 molarity to X equals 0.1 molarity OH negative. Methylamine CH3NH2 is a weak base that reacts with water according to the above equation. For this reaction, at equilibrium, Kb equals 4.4 times 10 negative 4. Cm of OH negative equals 0.1 times 4.4 times 10 negative 4 equals 4.4 times 10 negative 6 molarity. POH equals negative log of OH negative equals negative log 4.4 times 10 negative 6. The answer is 5.36. pH equals 14 minus 5.36. The answer is 8.64. So the final answer of this problem is pH equals 8.64. B. Calculate the pH change when 80 ml of 0.10 HNO3 or nitric acid is added to the 100 ml solution stated above A. So, this is the solution of this problem. N of CH3NH2 equals Cm times V equals 0.1 times 0.1. The answer is 0.1 mole. N of CH3NHNA equals Cm times V or volume equals 0.4 times 0.1 equals 0.04 mole. N of KOH equals Cm times V equals 0.15 times 0.08. The answer is 0.012 mole. CH3NH2 plus KOH equals CH3NHK plus H2O. 1 mole minus 1 mole KOH. 0.01 mole times minus X. X equals 0.01 mole KOH. N of KOH equals 0.0112 plus 0.01 equals 0.002 mole. V mu equals 0.1 plus 0.08. The answer is 0.18 letter. Cm of KOH equals N divide V equals 0.02. This divide 0.18. This equals 0.1 molarity. KOH to K positive plus OH negative. 1 mole KOH to 1 mole OH negative. 0.002 molarity to X equals 0.002 molarity OH negative. POH equals negative log of OH negative equals negative log times 0.002 equals 2.7. pH equals 14 minus 2.7. The answer is 11.3. And the final answer, pH equals 11.3. C. Calculate the pH change when 80 ml of 0.10 HNO3 or nitric acid is added to the 100 ml solution stated above A. N of CH3NH2 equals Cm times V equals 0.1 times 0.1. The answer is 0.01 mole. N of CH3NH&A equals Cm times V or volume equals 0.4 times 0.1. The answer is 0.04 mole. N of HNO3 equals Cm times V equals 0.1 times 0.08. The answer is 0.0008 mole. This is the balance equation. CH3NHNA plus HNO3 equals CH3NH2 plus NaNO3. 1 mole minus 1 mole HNO3 minus 1 mole CH3NH2. X minus 0.008 mole minus Y. So, X is equal 0.008 mole CH3NHNA and Y equals 0.008 mole CH3NH2. N of CH3NH2 equals 0.01 plus 0.008. The answer is 0.018 mole. V nu equals 0.1 plus 0.08 equals 0.18 liter. Cm of CH3NH2 equals N divide V equals 0.018, which is this divide 0.18, we get from this equals 0.1 molarity. N of CH3NHNA equals 0.04 minus 0.008 equals 0.032 mole. V nu equals 0.1 plus 0.08. If we add this, we can get 0.18 liter. Cm of CH3NHNA equals N divide V equals 0.032 divide 0.18, which is we get 0.032 from Cm of CH3NHNA equals N divide V equals 0.032 divide 0.18 equals 0.178 molarity. CH3NH2 plus H2O or water equals CH3NH3 positive plus OH negative. 1 mole CH3NH2 to 1 mole OH negative. 0.1 molarity to X equals 0.1 MOH negative. Methylamine CH3NH2 is a weak base that reacts with water according to the above equation. For this reaction, at equilibrium, Cm of CH3NHNA equals N divide V equals 0.032 divide 0.18 equals 0.178 molarity. CH3NH2 plus H2O or water equals CH3NH3 positive plus OH negative. 1 mole CH3NH2 to 1 mole OH negative. 0.1 molarity to X equals 0.1 MOH negative. Methylamine CH3NH2 is a weak base that reacts with water according to the above equation. For this reaction, at equilibrium, Kb equals 4.4 times 10 negative 4. Cm of OH negative equals 0.1 times 4.4 times 10 negative 4 equals 4.4 times 10 negative 6 molarity. POH equals negative log of OH negative equals negative log 4.4 times 10 negative 6. We can get 5.36. pH equals 14 minus 5.36. The answer is 8.64. The final answer of this problem is pH equals 8. Let's proceed to problem number 2. Calculate the pH of 50 ml of 0.100 molarity methylamine solution after the following volume of 0.100 molarity HNO3 or nitric acid were added 0. So here is the solution of this problem. N of CH3NH2 equals Cm times V equals 0.1 times 0.05. You can get 0.005 mole. N of HNO3 or nitric acid equals Cm times V equals 0.1 times 0. The answer is 0 mole. So, if we balance this equation, we can get this answer. CH3NH2 plus H2O or water equals CH3NH3 positive plus OH negative. 1 mole CH3NH2 to 1 mole OH negative. 0.1 molarity to X equals 0.1 molarity OH negative. Methylamine CH3NH2 is a weak base that reacts with water according to the above equation. For this reaction, at equilibrium, Kb 4.4 times 10 negative Cm of OH negative equals 0.1 times 4.4 times 10 negative 4 equals 4.4 times 10 negative 5 molarity. POH equals negative log of OH negative equals negative log times 4.4 times 10 negative 5 equals 4.357. Using pH plus POH 14, we can get the value of pH. pH equals 14 minus POH equals 14 minus 4.357. The answer is 9.647. So, the final answer of this problem is pH equals 9.643. B. 25. And here is the solution of this problem number 25. N of CH3NH2 equals Cm times V equals 0.1 times 0.05. We can get 0.005 mole. N of HNO3 nitric acid equals Cm times V equals 0.1 times 0.025. We can get 0.0025 mole. If we balance this equation, we can get this CH3NH2 plus HNO3 nitric acid equals CH3OH plus N2 plus H2O or water. 1 mole minus 1 mole. X minus 0.0025 mole. We get this from this. X equals 0.0025 mole. N of CH3NH2 equals 0.005, which is siya, minus 0.0025, pero na to siya gikuha, equals 0.0025 mole. T nu equals 0.05 plus 0.025. We can get 0.075 letter. Cm of CH3NH2 equals N divide V equals 0.025 divide 0.075. The answer is 0.033 molarity. CH3NH2 plus H2O or water equals CH3NH3 plus positive plus OH negative. 1 mole CH3NH2 to 1 mole OH negative. 0.033 molarity to X equals 0.033 molarity OH negative. Methylamine CH3NH2 is a weak base that reacts with water according to the above equation. For this reaction, at equilibrium, Kb equals 4.4 times 10 negative 4 cm of OH negative equals 0.033 times 4.4 negative the power of negative 4 equals 1.47 times 10 negative 5 molarity. POH equals negative log O of OH negative equals negative log of 1.47 times 10 negative 5. We can get 4.833. Using pH plus POH equals 14, we find the pH value. pH equals 14 minus POH equals 14 minus 4.833. We can get the answer 9.167. So the final answer of this problem is pH equals 9.167. C, which is 3. And this is the solution of this problem. N of CH3NH2 equals Cm times V equals 0.1 times 0.05 equals 0.005 mole. N of HNO3 or nitric acid equals Cm times V equals 0.1 times 0.003. We can get 0.0003 mole. If we balance this equation, we can get this answer. CH3NH2 plus HNO3 or nitric acid equals CH3OH plus N2 plus H2O. 1 mole minus 1 mole. X minus 0.003 mole. X equals 0.003 mole. N of CH3NH2 equals 0.005 minus 0.003. We can get 0.0047 mole. V nu equals 0.05 plus 0.003. If we add this, we can get 0.053 letter. Cm of CH3NH2 equals N divide V equals 0.0047, which is this divide 0.053. V nu equals 0.05 plus 0.03 equals 0.053 letter. Cm of CH3NH2 equals N divide V equals 0.0047 divided 0.053. We can get 0.0887 molarity. If we balance this, we can get CH3NH3 positive plus OH negative. 1 mole. If we balance this, we can get this answer. CH3NH3 positive plus OH negative. 1 mole CH3NH2 to 1 mole OH negative. 0.0887 molarity to X equals 0.0887 molarity OH. Methylamine CH3NH2 is a weak base that reacts with water according to the above equation. For this reaction, at equilibrium, Kb equals 4.4 times 10 negative 4 cm of OH negative equals 0.0887 times 4.4 times 10 negative 4 equals 3.9 times 10 negative 5 molarity. POH equals negative log of OH negative equals negative log of 3.9 times 10 negative 5, which is we get from this equals 4.41. Using pH plus POH equals 14, we find the pH value. pH equals 14 minus POH equals 14 minus 4.1. We can get the answer of 9.59. The final answer of this problem is pH equals 9.59. Let's proceed to letter D, which is 50. And this is the solution of letter D. SA plus SB titration. We can add 24.9 ml of NaOH. Moles of HCl equals 0.10 times 0.025 liter. We can get the answer of 0.0025 moles. Moles of NaOH equals 0.10 times 0.0249 liter equals 0.00249 moles. Moles of HCl left equals 0.00001 moles. Total equals 25 plus 24.9 ml. We can get the answer 49.9 ml. And the final answer of this problem is 0.0499 liter. Let's proceed to letter E, which is 55. The final answer of this problem is 2.63. Next, letter F, which is 60. This is the solution of this problem. N of CH3 and H2 equals Cm times V equals 0.1 times 0.05. We can get 0.005 mole. N of HNO3 equals Cm times V equals 0.1 times 0.06. We can get 0.006 mole. If we balance this, we can get this answer. CH3OH plus N2 plus H2O, which is water. 1 mole minus 1 mole. 0.005 mole minus X. X equals 0.005 mole. N of HNO3 or nitric acid equals 0.006 minus 0.005. We can get 0.001 mole. V nu equals 0.05 plus 0.06. If we add this, we can get 0.11 liter. Cm of HNO3 or nitric acid equals N divide V equals 0.001 divide 0.11. We can get the answer of 0.0091 molarity. HNO3 or nitric acid to H positive plus NO negative 3. 1 mole HNO3 equals to 1 mole H plus. 0.0091 molarity to X equals 0.0091 molarity H plus. pH equals negative log of H plus equals negative log of 9.1 times 10 negative 3 equals 2.4. So the final answer of this problem is pH equals 2.04. Number 5. Describe, explain, and draw the titration curve of the weak acid versus weak base. So first, what is weak acids and weak base? Weak acids are acids that don't completely dissociate in solution, while weak base, a base that upon dissolution in water does not dissociate completely. So this is our titration curve of the weak acid versus weak base. So as you can see, this is our titration curve. This is the weak base. This is the weak acid. So as you can see, the titration curve of the weak acid versus weak base has an increase in pH level at the beginning of the titration. It is caused by the anion of the weak acid that turn into a common ion. As a result, it reduces the acid ionization and after the increase at the starting point of the titration. The curve just changed in a slow or in a gradual way. In addition, the conjugate base of a weak acid is a weak base while the conjugate acid of a weak base is a weak acid. And
And that's all. Thanks.